Hey everyone, how's it going? Welcome back to part 3 of this hands-on with Maxon C4D level up workshop. My name's Ellie. I'm a trainer at Maxon, and I'm joined once again by a very good friend, Matt. How's it going, Matt?
Hello, how are we all today?
I'm hoping everyone's doing well. So let me
Yep, let's
just
see.
have a quick look
See
in the
what's
questions
going
area.
in.
Yeah, so we have got, so hey to Charles, Marcelo, Bern, Jay, Uriah, Wesley, Hannah, Will, Ahmed. It's so nice to see you guys. Thank you for being on this live with us. I really appreciate it. So really quickly, we're going to kind of like blast through this intro bit so we can get into what we're going to be doing today. The idea of this workshop, if you are new and joining us for the first time, is to boost Cinema 4D artists onto the next level of their 3D journey. So we're going to be learning Cinema 4D version 26 and Redshift 3.5, just as a kind of base idea so you know where we're at. Here's a quick idea of how we've separated this workshop or this course. We've separated over 6 different parts, and we've already covered weeks 1 and 2, which is when we had a look at version 26 for the first time, some of the new tools. We had a first look at Redshift 3.5, and we also did some polygonal modeling. And then last week, part 2, we had a look at some really fun stuff with volumes, which is, a nice broad topic where we went into Redshift fog volumes, rendering volumes, volume builder, modeling, and Matt created that incredible lightsaber. And today, part 3, we're going to be working with simulation. And we also have, 4, 5, and 6 there. And if you do want to have a look at a breakdown of the stuff we're covering over this entire workshop, in the handout section and go to webinar, there is an entire course outline. So feel free to, check that out and see what's going to interest you most over these next couple of weeks. Really quickly, we have some extra stuff that I just want to talk about. So we do record all these sessions. Pretty much majority of the sessions that we cover as a Maxon training team get recorded and they get uploaded onto the Maxon training team YouTube channel. So this particular workshop and this particular series is called Hands-On or Hands-On with Maxon. And we actually have a playlist on our YouTube channel that is titled Hands-On. So all of these sessions get uploaded onto there. And so already you can find weeks 1 and 2, which are also timestamped thanks to Dr. Sassy. And yeah, what our aim is to, by the next day, we try and upload the session. So today's session, once it's finished processing, etc., we will try and get that uploaded by tomorrow morning for you guys. We also have created some project files. So everything we work on throughout this entire workshop, you guys can have, you can use, you can break down the files, you can follow along, you can keep it as interactive as you like. And yes, you can have those project files. If there's anything that we ever do or create, so for example, a couple of these scenes today may not necessarily be on there, let us know, we can upload those as well. That is not a problem. A lot of you have already requested a trial extension. So if you didn't know, if you don't have access to Cinema 4D, if you don't already have a subscription or a license, you can install the Maxon app and you can activate the Trial of Maxon One, which gives you Cinema 4D, Red Giant tools, ZBrush, Redshift, all under a particular license for 14 days. And then we're actually extending that trial for the entire duration of this workshop. So around what's the last session's on, I think the 13th of July, and so a couple of days after that. The main thing here is you do actually have to install the Maxon app, you do have to activate the trial, and only then email us and let us know the email that it's under if it's different to the email that you are emailing us with. So yeah, we've been doing a whole bunch of them. So our aim is to do like a whole group every single week. So the chances are if you emailed over last week, it's now been done, apart from a couple of people who haven't activated, but I'll try and get through responding to a few people tomorrow. Again, if you've not been on any of our sessions before, we love to keep them as interactive as we can. If you have a look inside the GoToWebinar control panel, there's actually a questions area. And inside that questions area, you can ask us questions. So feel free to ask us questions about anything related to the stuff that we're showing. If it's slightly off topic, don't worry, we'll try and get to that as well. But you have the benefit of having both myself and Matt, so 2 Maxon trainers to help you out with these questions. And we'll try and show some stuff live as well, because that could be fun. Finally, feel free to share your work with us. I know a lot of people like to post things on socials, whether it's Twitter, TikTok, Instagram, Facebook. We actually have our own hashtag for this particular series, and it is hashtag HOWMaxon. And I know a load of you already use it, and it's really interesting seeing the stuff that you all create. So feel free to hashtag us or even just tag us in that. And then finally, all the stuff we just talked about, all of this information can be found in that area, that handout area inside of GoToWebinar, including all of the links to like project files, the YouTube playlist, and the course outline. So today, session plan for today, working with simulation. And I'm really excited about this topic. I mean, to be fair, I've been excited about all the topics. I know you have as well, Matt, but this one's pretty cool because we all know simulation dynamics is a very fun thing inside of Cinema 4D to play with. And as of version 26, we have some new fun things to play with. And that is a new set of simulation tools, in particular for rope and cloth. So we'll be diving into those, looking at the different tags, the different settings, as well as some of the other tags, so things like rope belt, connector, and colliders, and seeing how they can all work together and what exactly they mean and what they can do. We're also going to dive into adjusting simulation project settings. And you're probably thinking, that doesn't sound super interesting, but when it comes to working with simulation and dynamics, we can get intersections, we can get collision issues, and so we need to learn how we can solve these. And we now have a new set of settings that we can control and adjust to change and fix some of these errors. So it's quite an important topic to definitely cover. And then, as you know, we like to keep things nice and practical here. So we're going to be creating our own rope simulation, combining rope dynamics and MoGraph. And then, so that's going to be kind of the first half. And we thought we'd then introduce the C4D's native particle emitter as well, because we didn't get round to that in the beginner's workshop. And it is actually quite a powerful tool, especially when we combine it with Redshift. And so that's what we're going to be doing, looking at the particle emitter, looking at forces, so wind, turbulence, gravity, and then combining all of that with a little bit of Redshift to create our own particle simulation. So I guess I wanted to keep that bit, as short and sweet as we could, so it didn't take up much of our time, so we can get into it. So let me chuck it over to you, Matt. Are you good to go?
Oh, yes.
Oh, yes. And also, I just want to give a quick shout to a bunch of other people in the questions area. So while that sends it over, I want to say hey to Frank, Jens, Brian, Gray, Kelly, Charles, Mike, Chris, Anders, Mimo, Ronnie. It's great to see you guys. Thanks. And then Chris and Lucas, thanks so much for, saying hey to us and being here live.
Someone's just asked where I am. I'm here.
Matt is here.
I think I'm here.
You can. I think you can choose to hide us and hide our cameras. And so maybe I thought so much.
My camera is showing, my screen is showing, well, which my screen is currently showing not a lot, but there's Cinema 4D for you. So, hooray! Cool. Right. So, simulations. This has been actually quite fun to play around with. There has been, of course, some form of simulations and dynamics inside of Cinema 4D for quite some time. And the engine that it was using was called Bullet. Now that engine still exists, and you'll be able to see that. Ooh, I need to have an object, don't I? So if I go to my tags, we can see that we've got Bullet tags, and they are the previous engine's dynamics. So rigid body, soft body, collider, and a ghost collider, a ghost body. They are the old ones. So they have yet to be updated to the newer simulation engine. So the new simulation engine, pop down here, as you can see, we've got a few things that we will be looking at. So cloth, rope, connectors, cloth belts, rope belts, colliders, and things like that. And we should have a chance to look through, I think, 5 of those today, which should be really cool to kind of play with. So I'm going to do my normal explain kind of what they do and how they work. and then I'm going to build a little bit of a tiny scene that shows you some of them, and then we'll pass over to Elly for some funky stuff that we can add in with motion graphics sides of things. So the new engine runs on now, is it, oh, I've forgotten already the acronym, XP something, Elly?
BD.
XP? It is XPD, isn't it?
BD.
XPBD.
Yes.
I can't remember what that stands for.
Which is extended position-based dynamics.
So what it does, it converts the forms and geometry or splines into sort of poles and things, and it works on a kind of almost volume-based dynamic system as opposed to a geometry-based one like I think Bullet used to. In effect, it's faster. Not only that, but you can use it on the GPU to calculate graphics cards rather than the CPU, central processing unit, which can be a smidge slower. So let's have a look at some of the dynamics simulation things that we can do. So as you can see, they're all under the simulation tag. So, you know, very simply, I believe cloth does as it did before. So I'm just going to not create a cube. I'm going to create a sphere, and then I'm going to create plane. And then on my plane, I'm going to create a cloth tag, and on my sphere, I need a collider. So cloth says the top one will be cloth. Collider says I will interact with cloth effectively, and I will collide. And press play, and it's thinking about it. My laptop is not happy. Ooh, come on. Ooh.
It might just be the first time it's doing it.
Yeah, it's got to think and cache, which is weird. But there you go. Whee! And now it plays back, and it's really, I'm used to it being like the other one. So it was quite a different visual to get rid of. So let's make it bendy. To do that, you can look under the plane. So that's got my cloth tag, and that's got a tag. That's got the tag. So basically, what information can I change? So let's change the bendiness, 0.5%. Look how much that sort of flops around a bit more. Now it is kind of dependent on the amount of points and polygons that my object has. The more it has, the slower my thing will be. But let's change this. Let's change it to full-on bendiness, or 1. Whee! What about stretchiness? Should we make it stretchier? Let's see what upping that a bit does, and see how much it sort of pans out.
I would do like a high number. Do like 10 or 20 or something.
I always like to go crazy with numbers. I thought changing it by 10 decimal places would have been enough, but oh, there we go. That's a bit floppier,
yeah,
which I really like. That kind of
like basically like off.
Yeah, near enough, like 0.0001. And as you can tell, we didn't used to do 4 decimal places, but now we do. But I like that. You know, you can kind of get the feel of the object. There's a whole load of other stuff to look at as well, which unfortunately we simply won't have time for, like ballooning, plastic deformations. There's stuff you can do with the dresser tag, which I quite like. Making pillows, duvets, and things like that's quite cool. But the more important stuff is the stuff in yellow, because this is what's new. This is what's changed. You know, we've got the tag, the bendiness and stretchiness, and you can choose. Oh, whoops. You can see they've got little drop downs, so you've got maps that you can choose so that it can be bendy and stretchy in certain points. And I'm assuming that will be a vertex map, drag and drop there, where it will understand which points it can bend, which points it can stretch. So you can make particular parts of an object bendy and stretchy and use the cloth dynamics, and not other parts, which I think is an incredibly fun thing to do. So that's kind of the cloth stuff. It's very similar to what we had before, except, you know, we can turn on tearing and see what it does. If do I lower that? There we go. Oh, shattering, which isn't the best there, but at least it puts it all together. Tearing past. No, too much. 109. There you go. That's a bit better. That's kind of cool. Kind of a bit like crazy paper, which is quite fun to play with. But I just wanted to show you that and turn that on really quickly so that we've got a slightly better tearing algorithm than we had done previously. One of the other fun things, of course, that we're all jumping up and down about is the rope simulations that we now have. And it's, you know, fairly simple in the fact that it works with splines. So it's kind of spline dynamics and spline IK. And I need a spline, obviously, for this to work. And just to give you a you know, quick indication of how this works, I have my spline. I have my uniform points. I will need to make it editable, otherwise I can't select the points of my spline, you see. So I have to make it editable, boom, and then I get my points. And to this, I will add my new simulation and I will add my rope, boom. And if I press play, it's very exciting, isn't it? It's because I've got the points selected. So don't forget, deselect the object. Otherwise, it's going to show you the geometry. Wow, isn't that exciting? It falls. But not really. So let's fix some points so we can see something happen. Let's fix 1 point. To fix a point, I need it to be editable so I can get to the points. I select my points. I go to my tag. I click set. So this is displaying anchors. So if I click set and then click play, need to deselect it. Whee! So one anchor there is keeping that point at its fixed point where the original spline was, and the rest just flops off. Okay, and I can add more points to that if I want. So let's go back to my arc. Let's select 2 points and select my tag again and click set. Now I've got 2, deselect, press play, floppy. There we go. And you get quite nice sort of movement with that. And considering that the arc itself only has 4 points, the rest of the information is being created by this intermediate points. And a uniform set of 8 actually gives you a quite nice look. So for every point in between, so for every one of these points, there's sort of 8 intermediate points that you can't actually see or click on in between, understanding that there's more information that you can make dynamic. So that's really quite cool. Now, there's a few other things that we can kind of quickly bolt onto that. So let me stop that. And then I'm going to go back to my, actually, I'm going to delete that and just start again. So in an attempt to use quite a few of these, we're going to create a kind of, well, a washing line effectively, but it works quite well. So I'm going to start with an N side and I'm going to set its edges to 2 because effectively that gives me a straight line. Don't forget, turn your points to uniform, although you can do that after you make it editable and then make it editable. I now have 2 points. That's all I've got, 2 points. I'm going to go to my tag, simulation, let's add a rope tag. So I've got that, press play, deselect, falls off. Great, I know the dynamics are working, fantastic. I can set the side if I want, set the points like I did earlier, but using another one of the tags, there is a simulation, there is a rope belt tag. What I can do, I can pin these points to particular objects. So with one rope belt on, it says, hey, what object and what point do you want me to use? So let's create an object. Let's create a cube. Let's make this cube 20 by 20 by 20, and I'm just going to move it to one end. And I'm just going to check that it's roughly over that end, which it is. Oops, if I look at the right view, really, doesn't it? There we go. It's near enough. The points around it, which is fine, which is what I want it to do. So my end side says, which object do you want to pin me to? And I say I want to pin you to the cube. And then it says set, and set means which points do you want me to pin? So I'm going to select my line, click my 1 point, which I can tell is in there because I'm just going to turn off my cube and I've got that point. Select my tag and click set. So I've set 1 point to that cube. Now if I press play, it does what it did before, but it's attached to the cube. So it means wherever I move my cube, oh, that's a little bit crazy, but Ellie is going to be going over some interesting things about how to solve those. I can move my cube around. So I can choose to set my object towards something, which I quite like. So even if I go back to the beginning, and you can see that my cube is quite a bit higher, if I press play, it pings to it and goes a bit doolally. So I don't really want that, and I'm going to undo the movement of that until it's back where it was. What if I had two objects? Well, let's copy and paste my cube. So I have cube 1. Let's move it the other side. I'm just going to check with view number 4, F4 on my keyboard, just to make sure that it's roughly there so that I can view the front. And with my end side, I'm going to create a tag, and then I'm going to create an simulation, and I'm going to do another rope belt. And this says, cube 1, I want you to pin to the other side. And this time I'm going to select my other point, and I'm going to do set. So now if I do play, oh, and let go of the thing, I have a rope between two things, which is really cool. Okay, so that gives me a bit of sort of bounce, which is quite nice. So I have shown you the rope tag and the rope belt. Woohoo! Okay, let's see what else we can do. Let's create ourselves something to go on our washing line. So a plane 300 by 300. That might be a bit small, big. 200 by 200. And let's change its orientation. Let's move it down. Let's go back to the beginning to make sure everything is set. So there I have my washing line, or my washing on my near my washing line. And I need to add a connector to this. So we're going to connect to my rope. I also need to make it cloth as well, don't I? So let's do cloth, otherwise it's not going to do much at all. Connector will connect it, but cloth won't do anything fun. So I need to set my connector first, or at least so that I can show you what I'm doing, and it will search for something to connect to. And if I do create, nothing happens, because I need to drag and drop the end side in there to say connect to those points. I might need to increase my search radius so that it can find it. What did we set that to before? 20? Have I done this in the wrong order, or do I need to make it editable?
I'm sorry, I was answering questions. What was the question again?
I've got my plane. I should be able to use my connector. Point restriction, maximum connections 0.5.
Yeah, so what you need to do is you need to set up your dynamic or your simulation first on your plane. So set it up as a cloth.
Okay,
because
right.
so the connector is looking for the two simulation setups, but
there we go.
One.
There can be only one. Oh no, not belt on. I didn't need that at all. Simulations and cloth. So this says I am cloth, which means it will fall and disappear, which means it's got some form of dynamics. And then with my connection, let's create. There we go.
Yeah.
Thinking we didn't have to do it in that order. So as you can see, it's worked because the connector has connected from the one dynamic object, as Ellie said, the cloth object says, hey, look, I'm clothy, to the points. So the search radius means how far out it will connect to those lines. So if I create here, you can see it's too far away. It isn't within 0.41 centimeters. Is it within 5? And if it's within 5 and create, it will create some. Let's try more points. Let's say 10 points. And let's say within 20. And all of a sudden, I get stuff that will connect, which is quite nice. And now, the moment of truth, we press play. and I get that's very stiff, isn't it? Can I do it in a different order? No, it doesn't make a difference in a different order. So let's change the bendiness to something like 5.
And if you do maybe some stretchiness, and what are your segments on the plane currently?
Yeah, my plane segments are really low just for the simulation at the moment. So
Yeah.
if I go back to the beginning, let's make that 50 by 50. This should be interesting. Now, I will need to go back to my connector. You can see that it doesn't understand because I've changed the geometry. It's gone, oh, this is different. So let's recreate that. And that creates something very different. And now we press play. Whee! Clotheslines. And because I've got one of my blocks, I can move stuff up. Oh, that's going to be fun. I didn't like that one at all. But we're going to look at settings, how we can change those. But it's really interesting how, I just love how the material kind of works. Obviously it goes a bit sort of jaggedy, but there's smoothing things and things you can put on that which can really emphasize and change how your sort of plane works and how smooth it looks, and gives you a nicer effect. And then let's do something crazy. Let's get, ooh, that's a big sphere. I'm going to get the sphere, I'm going to put it there, and on my sphere, I'm going to create a collider, and then all I want to do, let's give myself some actual room for this animation, because it does go a little bit, you know, you need more time when working with simulations. 90 frames isn't really enough. So at this point, let's keyframe my sphere. Oops. Just moving forward, and you can see that it should interact with the laundry as well. I say laundry. Whee! Look at that. It's got stuck. It's good friction on that as well. Look at that. That's cool. Right, so let's loop that back to only being about 150 frames, just so we can watch it go. Whee! Okay, and you can see that that's really quite quick. You know, that's not chugging, that's not really very slow. There was the first initial kind of dynamics sort of set, and then everything else in this scene has been fine. So there you go. That in one scene, we've got the cloth, we've got the rope, we've got cloth belt, we've got collider. You know, we've sort of maxed out most of those, except I think the only one we haven't done is cloth belt itself, but the connector's doing that for us because it's connecting to a simulation. Cool. Any questions?
Yes, we've had a couple of pretty good ones actually. So James was wondering, how would you delay this dynamic or simulation behavior so it doesn't occur right at the beginning of the timeline, but say on frame 300 or something?
Good question.
So the way that I would do it, or the quickest, laziest, dirtiest way would be to disable the dynamics in the basic tab,
Yeah,
and then
yeah,
to
that's turn it
enable
on.
them. Yeah, and then to enable them at the frame. That would be the easiest way of doing it.
I think you're right, because there doesn't seem to be in like other dynamics ones. I mean, there is in the collider. No, I think the colliders are different.
A
Yeah, so if we
potential,
turned,
yeah.
yeah, I'm just going to try that. So let's turn that off and just see what happens if I press play. So that falls to the ground. So you'd need to have that off as well, so nothing happens, and then say on frame.
Yeah, I don't know how well it works in like a simulation with connectors, but I think if it was just like a single, I mean, it may work, but if it's just like a single sim or a single kind of like this would work on like bullet dynamics as well. I would, just go between enable and then, or disable to enable on.
But you can't do that with the cloth tag. There's no keyframe. You can't do that.
Oh.
You can only do it with the rope, but you can't do it with the cloth. Interesting. There's an even dirtier method than what you were thinking, which is you bake it out, you bake it to alembic as keyframes, and then you shunt it over.
Oh, that's why. Yeah, that was going to be my second
That's
go-to.
that's the really gritty way, but obviously that wouldn't then technically be a dynamic simulation. Well, you start with dynamics, but then you cheat afterwards.
Yeah. So bake the simulation as an alembic. Yeah. But then
I think
you
that would
wouldn't
be
then
your
be able to
only.
change your dynamics.
Yeah, I think that's it. Unless you can do something interesting with cache mode, but I'm not sure it will do that. Anything else?
Yes, let me have a look. So Charles was wondering, do you have any idea why the dresser tab is disabled on the cloth tag? And I do. We have to hit the magical C key because it has to be editable.
Yeah. So you can't dress something that isn't polygonal. This is kind of the advantage of the new simulation stuff, is that you can do simulation and dynamics on non-editable objects, whereas the dresser I can select, but I can't do anything until the plane is editable. Oops, what did I do? And now the dresser mode activates as soon as the plane is editable. Cool. Next.
Cool. Mike was wondering, can you keyframe bendiness? I am unsure.
Yes. Anything with a
Lovely.
little animation dot you can keyframe, so you can make something bendier or less bendy, so something could in theory kind of droop.
Cool. So we have a question here, and I'm not 100% sure. So Jeremy was wondering, why would you use the connector instead of the cloth belt? So that I know the answer, but does the connector have the ability to use vertex maps? Was there a vertex map selection in there?
No, and I'm assuming the reason why you would use the connector is because we actually don't have any points to connect it to on the spline. Is that the same reason you were going to say, Ellie?
So I believe the reason you would use Collider over cloth belt is Collider allows you to combine multiple XPBD simulations together, i.e. rope and cloth, whereas I
Yeah,
believe the cloth will only allow you to be pinning parts of a cloth to
a
something
polygonal
else.
object, I think.
Yeah,
Yeah,
not another simulation.
and
So that would be the two.
I don't think if I was to swap the connector out for a cloth belt, that wants to belt on something, but I don't think, because I haven't got the points to draw it,
Yeah.
it won't belt onto that. There's no geometry, there's no points technically in this spline, so I don't
Yeah,
think
so the
it would
cloth
work.
belt would be if you were pinning like a t-shirt to a character, you would use the cloth belt. If you are looking to combine
Or a flag.
simulations together, or a flag or any kind of geometry, but the cloth belt would be if you are the connector would be if you are combining two different or multiple different XPBD simulations together. And the important thing with that is bullet dynamics and simulation dynamics will not work together with the connector because they are different frameworks.
Cool. Okay.
Cool. Yeah,
That's
I'm pretty sure that's most of them. So the final one was just from Deborah saying, will you guys be sending the recording later? So yes, these sessions are recorded and they get uploaded onto the Maxon Training Team YouTube channel by tomorrow morning.
Cool. So let me throw you the screen.
Let me turn my camera on.
There we go. Turn mine off.
Okay, show my main screen. Good, that worked. Right, let me find my cinema 4D. So yeah, if I didn't miss any questions, feel free to ask them again, or Matt can check them out. But I've been trying to get to as many of them as we can. Right, so hey everybody, how's it going? Let's dive into creating something. So if anyone saw the hero image for this, I can actually even open up the project file, which is this one here. And let's have a quick look at just creating like our own simulation. And what we're going to do, we're actually going to be combining this with MoGraph. -91, just to make it a bit quicker. And this is the kind of thing we're going to be creating. And it's a little bit slow just because I've got a bunch of geometry and a bunch of like subdivisions and points just as we go. But we can still see it's still working pretty quickly in comparison to how it would be before. So this is the kind of thing that we're going to be creating. And we're also going to take a look, as Matt was saying, at the different project settings and how we can fix and solve errors and intersections and all that kind of stuff. So feel free to ask any questions. So let's build this from scratch, and we're going to do that just by setting up a few different things that's going to help us to first understand the settings, understand what these things do. So I'm just going to create a floor. So I've got a plane. I'm just going to name it floor so we can keep track of everything. And then the super quick way of creating a single sort of like straight line spline is grabbing ourselves an end side and changing our sides to 2. If you're following along and I'm going too quickly, just let me know and I can always repeat a step. That is not a problem. So we have our end side, and this is going to be our rope spline. And we are just going to, let's make this like 100 centimeters in length, even though it says radius, because we only have 2 sides, it works as our length. And I'm going to rotate it 90 degrees. Cool. So let me pull this up. So I've made my spline yellow, so hopefully that is a little bit more obvious for everyone to see. Actually, I might even, you know what, I might even make it red to make it even more obvious. There we go. Okay, now we're just going to set up the exact same tags that Matt just showed us. So on our rope spline, we're going to right click, come into simulation tags, and we're going to drop a rope tag on there. And I'm not too fussed about the settings yet. And then on my floor, because I need to set up a collider, otherwise it's going to fall straight through the floor, we need to set up our collider. Okay, so if you press play, it's dynamic, but it's not really doing what we thought. We're expecting it to kind of coil together, right? There's a reason for that. Inside my rope spline, inside my object, my intermediate points are set to adaptive. So it's just got 2 points on either end, and so it's not able to kind of subdivide and coil in with itself. So there's a couple of different things we can do. We can set it to natural, uniform, or subdivided. For me, I like to go with uniform because it gives me a input value for the number of points, which in turn will be like the number of subdivisions that we're going to be going with. And let's go with 40 for now, because the number of points will actually determine how this simulation looks. So we'll look at that in a sec anyway. So if we play this through, we can see it's now doing what we thought it would do. It's now starting to curl in and coil in on itself like a rope would or a piece of string. So we take a look at our tag setting. So Matt's just basically shown us these, and we now know what they do. We know our bendiness is the amount of bendiness between each of our points or each of our particles. So we'd refer to them as particles now because of the way that our simulation is set up. So if I drop this to a really, really low value, it's going to keep its structural, it's going to try and keep its structural shape. It's going to be quite stiff. So you can see here that it's almost like bouncing back on itself. And then we can do the opposite by, you know, entering a high value, and then we're going to have it coil in on itself quite a bit. Stretchiness, again, is the stretchiness between each of our particles. And so we're not really going to see that here because it's kind of falling straight down. But if we started to add some geometry in the way, or we pin some of our points, that's when we can start to see our stretchiness. Bounce, friction, things that we are used to from our previous bullet dynamics. We're used to controlling the amount of bounce for our points or particles and the amount of friction. So we can prevent some of the jittering, some of that sliding around by increasing friction values. So 5 should be like a nice number for this. But for me, the most important setting is the radius setting. And that is because if we come closer into here, hopefully if I can get a good enough angle, you guys, if we ignore the intersections for now, we'll just pretend they're not there, you might be able to see, or hopefully you can see, that no parts of our spline are touching any other parts of the spline. And it's also not going to be touching this plane, bar the intersections, but we'll just ignore those. And this is because this radius value is setting the radius of each particle that is now making up our spline and making up our simulation. So if I enter a larger value in here, so we've gone with 2 centimeters, and I play this through, what you'll notice is there is now a very large gap between the floor and my spline. And so the reason this setting is so important is because when we turn our spline or our spline dynamics into geometry, we can now control the exact radius value of that geometry and match it to the radius value of our simulation particles. And then we're going to prevent any kind of intersection issues, which is just something we couldn't really do with this much control before. So let's go the opposite way. Let's do a radius of 0.1. And the reason I'm going to do 0.1 is because we're going to get some collision issues because it's such a low value. And that's good because then we can look at fixing them. So let's sort of like come a little bit out here so we can see this a bit clearer and play this through. Cool, so we've played that through, and as we can see, we have a whole bunch of collision issues going on, which is great. It's always good to see this stuff because this might happen when you create a simulation. You might find, actually, we're getting some intersections. And so at this point, what I would now do, or what we would now do, is we would go into our project settings and our simulation settings. So if you hit Command D, it's going to open up in the bottom right our project settings. And by default, it will show you the project tab. And this is where we can change a bunch of different things, display, FPS, we can look at Cineware stuff. And so our original previous version of dynamics, which is our bullet dynamics, can be found under the bullet tab. And so if you've worked in Cinema 4D before, and if you've worked with our dynamics before, you will recognize these settings. These are the settings that we used to change when we had to try and fix our collisions and our scale and our steps per frame. But as we know, or anyone that's tried to use these settings before, the more you increase them, it can have quite a negative effect on speed and performance, even if you just increase them a little bit. And we can also see that we don't have loads of control. Like, we have control of steps per frame and a collision margin and some error threshold, but that's it. If we dive into the simulation settings, so remember the simulation settings are going to be our new ones, our XPBD, we can see we have a lot more settings, we have a lot more control. And the main one here, as Matt was saying, is we can control our simulations on either the CPU or the GPU. We have our gravity and our scene scale settings that we're used to, so we can actually remove the gravity in our scene, in our simulation, by actually zeroing it out here, or we can just adjust it. So for me, in the final scene that we did, the original project file, because everything was happening too quickly, I actually just reduced my gravity, and it creates this like nicer slow-mo effect. Okay, so let's have a look at some of these settings. We won't spend too much time on here, but they're definitely super useful things to know when working with simulation. Substeps. So each frame is subdivided into a a number of substeps depending on the value here. So each frame at the moment is divided into 20 substeps, and the particle position, velocity, and constraints are going to be calculated at each substep. So what that means is the more substeps we have, the more accurate our simulation and our collisions are going to be. So we can up this value. And what's nice about these values here, because we can see this, the simulation system is really quick and it's really kind of powerful. We don't have to worry about upping them by like 1s or 2s. With substeps, we can go pretty high. This isn't going to solve everything, just to lower your expectations. But it solved some of it, and we're getting a slightly different look in our simulation. So that's our substeps. Iterations is how many times our substeps are then calculated, so we can increase the amount of times these are then calculated. And then our smoothing iterations is going to create a smoothing out of that wiggling and that jittering. So we know when working in dynamics and simulation, sometimes when everything comes to kind of the end of the animation, everything like tries to get to the point where it should then be still, we can get some like jittering and movement going on, which we don't really want to see. So we don't have too much here. So this isn't actually too bad. We have a little bit going on here. This is sort of giving us a little bit of like weird movement. So we could up this to a value of 1. And so already we can now see we're getting a little bit closer. So we've just got 2 intersections here, and that's fine, because what's great about these settings is they all work together to solve all of these different issues and errors. So you don't just have to increase substeps to like 100 just to fix it. So what we can do now is we can still fix this stuff by affecting and adjusting our collision passes. So dampening, I know we've kind of like jumped over dampening. Dampening is a way of adding a smoothing to the simulation and to the kind of like the visual side of things. So if I increase, actually, I'll play it on 2% to give you like a comparison, and then I'll play it on a high value. So we can see how that happened. If I enter a value of 20%, we can see how it's slowed and smoothed the entire thing, but we're also getting now a slightly different looking simulation. So whereas before we had a really nice tight coil of our rope, we're now getting a slightly wider thing, and that's what happens when we adjust these settings as well. So let me put that down on 2 so we can get some of our intersections back. Okay, so we're still getting some intersections, which is cool, which is good. So we have collision passes and post-collision passes. So what's going to happen at the start of every single frame or every substep, our collision, there is something called a collision detection. And so twice this is going to happen because we have 2 collision passes. And so it's going to calculate the position and the constraint information and the speed of our particles. And then it's going to then prevent those collisions from happening. So sometimes if a particle is moving so quickly, it could happen between a frame, and therefore it could like effectively get through this collision detection. Whereas if it's happening twice, or we're preventing this from happening, we can then do post collision passes, which is the exact same thing, but it calculates this information at the end of a frame, so it's more likely to catch any of that extra movement or intersections that could happen. So let me sort of increase. With collision passes and post-collision passes, I would recommend going up by single values as opposed to doubling like I did with the substeps. Okay, so now, as we can see, we have absolutely no intersections going on, and all we really did was just up. So we doubled our substeps. We added a smooth iteration and a second iteration here, and then we just increased these values by just 1 or 2. And now we've completely solved those errors. And so it's really great having all of these different settings now. So really, no matter what scene you're creating, there are multiple ways for you to try and solve these problems, which we didn't really have before. But one thing I do want to talk about is we can all agree the simulation looks very different to how it looked originally. Well, the way that we can bring some of that stuff back is to go back into our rope settings. Now we've almost fixed our simulation settings. We can come back into here. Maybe we could, increasing the number here, the number of points is going to increase the look of kind of coiling. And that's because we have more subdivisions. Therefore, we're going to have more bendiness. We're going to have more stretchiness because we have more particles making up our object. So I'm going to put that on 80. And now we can see we have this going on. And we can see again, we have some intersections, but let's see if we can fix these. Maybe we could go on to like 15 and do some post-collision passes on here. And this should, it's making fun of me here because it knows I'm live. What should we do? Let's try increasing substeps. Okay, good stuff. There we go. So we've fixed that now just by increasing our substeps. Great, so now we've set up our simulation, we've set this up, we can actually start to turn this into some geometry. The way that we do that really easily is by using our generators. So what I might do is in my rope spline, I'm going to change this to a value of 0.5. I'm then going to grab myself a sweep and drop my spline into my sweep generator. And with the sweep, for anyone that hasn't used it before, it requires two splines. The first spline, which is this one here, is going to be like the shape that it makes up, that is swept across. And then the second spline, which in our case is going to be a circle, is going to be the shape of our mesh. So it's going to look like a sort of tube or a piece of rope. So if I grab a circle, the really important thing here is remember inside of our rope spline tag, our radius is going to be controlling the radius of our particles and in turn the radius of our intersections. So if I drop my circle into here, it's going to go crazy, and I put a radius of 1 centimeter and then play this through, and we come a little bit closer, we will see that we're actually getting some intersection. And this is because we need to make sure this rope value and this geometry radius value are matching. So let's go 0.5. And for the sakes of this, I'm actually going to just drop this down, and this down. And we're still, I don't think we're getting any issues there, which is cool. Cool, so now we have our geometry and we have no intersections happening because we've matched the two radius sizes or radius values. So from here, what else can we do? Well, we could drop it inside of a subdivision and then we'd get that really nice smoothing. Bear in mind, this will then slightly slow down performance because we are subdividing our geometry. So let me just play this through and see. Still pretty good considering we've got subdivisions on there. But now I want to show you how you can combine it with the MoGraph tools. So in the original scene file, this that we created, if I just sort of get my subdivisions back on, we've just created that entire setup that we just looked at there. I then duplicated all of them and just repositioned them and adjusted their rotation, which is fine, which is great. That works. And as we can see, we had our nice looking animation, some nice still looking heroes, but a easier way of working or using MoGraph tools and using the cloner is going to allow us to easily redistribute and rotate and change some of our rope instead of me having to manually do it myself. And there's a couple of other benefits to it as well. So for the sake of this, I'm not too worried about my subdivision surface just because I want things to be nice and fast on this session. So for anyone who doesn't know, I'm not going to go into too much detail about the MoGraph cloner. We'll probably be covering it a bit next week, but we also did an entire session on MoGraph on the beginners workshop, which is in the hands-on playlist from R25. But inside of our MoGraph menu here, we have a bunch of different MoGraph generators, and we have something called a cloner. If we grab a cloner and we grab anything, any object, So in my case, I'm just grabbing a cube, drop it inside my cloner. And then we have our cloner here. Matt, do you know where my axis has gone?
Is it off on your filter? On the left.
Oh,
Go
sorry.
to, yeah, axis, Alt D.
How on earth did I
I
accidentally do
occasionally
that?
do that if I mean to go to the project settings and I accidentally set my
Oh,
axis off.
yes. See, thanks. I'd
It's
have
all right.
been lost then, like
Common
session
problem,
over.
do that too much.
I just wanted to show the cloner for 5 seconds. What did I do? So yeah, quickly to go back to the cloner, it allows us to clone geometry. So we can see now we went from having a single cube to having a grid array of a 3x1x3 of cubes. We can adjust the sizing, and then we can begin to use effectors and create some cool geometry. But we'll save that for next week. I just wanted to quickly show you how the cloner works. So we're probably thinking, okay, cool. We're going to grab a cloner. We're going to drop our sweep into our cloner. Maybe we'll just, pull everything together a little bit, just so it's nice and close. And we press play. Oh, nothing's moving. Why is that? Well, the reason for this is because the dynamics are on the rope spline. We then turn it into geometry with a sweep, and now the cloner is cloning the geometry. The geometry that's being cloned is now effectively overriding the rope spline dynamics. So if we want to combine our simulation stuff with MoGraph, with our cloner, there is a different order that we need to put everything in. So the order that we want to do is let's pull out our rope spline, delete our sweep. And what we're going to do is we need to clone our rope spline first. So now we're saying, okay, we want all of these individual splines and we want them all to be dynamic. And then we turn it into geometry. So we've cloned our rope splines. We're just going to do a little bit of rotation just to pull everything back up. Something like this. And then it's not going to work again. I press play and again, it doesn't work. And the reason for that is because even though the setup is technically correct with the cloner and the spline, we then need to put the rope tag onto the cloner. So we're now saying, okay, all of these cloned splines, all of this stuff we just created, all of that now needs to be dynamic. Now if I press play, we get what we thought would happen in the first place. So we're now getting all of our dynamic splines. So this is the order in which you would need to do things if you are looking to incorporate MoGraph with them.
Noodles.
And then from here, noodles. Everyone knows I've been.
The
This is one
noodle
of
button.
my
Excellent.
favorite features. I'm loving it.
Noodling.
And so from here, we can then turn this into geometry in the exact same way that we did before, but one tiny little thing we're going to need to do. So again, grab your sweep, grab your circle, and what did I set it as? 0.5. Match that. Drop the cloner into the sweep and then the circle in between, and we only get one of them that is looking like a piece of geometry. And the reason for that is we need to use a magical tool called the connect. And what it's going to do, it's going to connect our cloner, and then the sweep is going to see that though all of the different cloned splines, as opposed to just seeing one individual one. We need to tell it that there's more of them. Look at them all. So what we can do, we can grab our connect, and I believe if I hold the option key and let go, what it will do is it almost replaces the position of the cloner, and then the cloner is now being branched off of the connect, and now we're getting our full geometry. And as I press play, we're going to get all of our little noodly things in here. And so you're probably thinking, okay, well, why have we used the cloner? What's the purpose for this? Well, if we go back into our original scene and we have a little look at it here, all these ones that I duplicated, I then adjusted their position, their rotation, so they looked like this. And it was a slightly longer process than if I'd used MoGraph. So what we can do, we can actually, because we now have a MoGraph setup and we have our cloner controlling all of our splines, we can take advantage of combining it with effectors. And so effectors allow us to affect our MoGraph geometry based on a set of rules. And those rules could be randomization of position, scale, and rotation, push them apart. It could do a variety of different things, control them based on a soundtrack. And then in effectors, we can use something called a field, which will work as a fall off area where this effect will happen on our geometry. Again, something we probably will be looking at next week in our motion week. So if I select my random effector, what we get is we get a little bit of movement going on. And so inside my random effector, what's it doing? So it's randomizing the position of our cloned objects, in our case, our rope spline, across the X, Y, and Z by up to a value of 50 centimeters. So if we just sort of maybe make this a little bit smaller, we can see we've just pulled that in, but we're getting some nice randomization. Then we can do the same thing with our rotation. And now with a couple of buttons, we've now created a similar kind of look without having to duplicate the initial setup, rotate it, position it, just so it's happy. So we're happy with where it is. And then from here, if we press play, we'll see that they fall and they sort of almost intertwine with one another a little bit differently. And then we could just steal this little shape model here.
Many noodles.
I find adding a piece, many noodles. I find adding a piece of geometry really adds to this, just because it can get caught in it and get intertwined. I just deleted that. That was wise. Right, get rid of those textures. Get rid of those textures. We don't need those, don't need those, don't need those. It's already got my collider on there. Let's make it a little bit bigger and pull that up. So now as you press play, it's going to collide with this and it's going to kind of tangle on it. And it's going to look a little bit more interesting than if it was just sort of falling onto the floor like it was before. And this is awesome. Pretty much the exact setup. And then I dropped it into a subdivision surface again, because we like a little bit smoothing, don't we? We do like that.
Would a smoothing deformer be quicker? I don't know. That's literally a stab in the dark.
Do you know what? Let's give that a test. So I'm going to play this through now with the subdivision surface, which, I mean, let's be honest, really isn't that bad.
No, I'm impressed, I have to say.
Yeah, I'm quite impressed. That's not too bad, considering it's got 2 lots as well on there. And we already had 80 points on here. Let's have a look. So I'm going to pull that out of there. Drop into a null.
Yep.
Smooth. Don't know why I sang that then. Soz everyone. Okay, so we've got some smoothing.
That's
okay,
fine.
So
it was great musical interlude.
I mean, well, no, I am absolutely not a singer. That is way quicker. Oh.
But.
Oh.
Has done something
quicker,
very odd.
But has failed the task.
Yeah, hasn't it?
That's interesting.
Yeah.
That's very interesting. So yeah. Sorry, smoothing. You've been relegated.
Yeah. Okay. I was just curious to say it was faster, but didn't work. So.
Yeah. It was great. Cool. So do we have any questions?
We do. Yes. Someone has Charles has asked, quick possible out of order question, and I think it's relating to the figures you were putting in. Is that only 0 to 20, or is it -20 to more than 20? I'm not
on
sure
which. So is this on command on our project settings? Let us know, Charles. Let us know.
I
Is it?
suspect if you check simulation in the project settings, the smoothing settings would not intersect. Oh. Simulate
Sorry.
before. Oh, simulate before generators. Ah, that's an interesting point.
Oh,
With the
but it
smoothing.
wasn't a generator. Let's give it a go.
It is generating. The connect is a generator. Oh, in the random effector, he was talking about the settings.
Oh, okay. Let me quickly try this, and then yeah, we'll take a look at that. So we've got my smoothing in there, and so we think if we do simulate before generators.
Oh,
No.
it doesn't
Yeah,
like
because I
that, does
think
it? That's a shame.
unless it's considering this a generator, because this is what's now messing it up.
Mm. Okay.
Yeah.
But with regards to what you'd put in the random effector.
Yes. Okay. So let's have a look at my random effector. So yes, it's going to randomize their position between values of 0 and 20. So it
Yeah,
won't be, whereas the plane effector, whatever we put in position, it will be like a linear, like the value will be set to 20 and therefore the positional movement will be 20 centimeters if we're ignoring fields.
yeah.
Whereas the randomize will be randomizing the position up to that
A maximum of
final
20
value.
or 20 centimeters or
Yeah.
20 degrees. Yeah.
Yeah.
Charles asked, can we get from -20 to 20? Um,
Oh.
um,
Hmm.
the we can't do
Um.
a range.
So I guess a way of doing that would be, what would we do? Ooh, that was a
Well,
great
in
question.
theory, you could do. It depends because 20 degrees one way is 20 degrees and 360 in the other. So it depends really why you wanted to go exactly from 10 to. Someone suggested effector tab minimum maximum. Uh, okay, so
So would that
in
effectively be what, 200?
20 that might already be doing 20 minus as well because you said 20 degrees and this is a maximum to minus as well, so that may already be doing it. That's an interesting one. I'll have to check that out. I've never dug
Yeah.
into those ones quite so specifically. I've never wanted to be specifically random, as it were.
Yeah. Yeah,
Okay.
that is an interesting one. Yeah, we'll find that out for next week.
Yep.
'Cause that is the
Another
interesting
question
one.
then, if I may. Does the
Of
collision
course.
problems depend on the system unit? For example, working in millimeters means values are always very small. So I think it
So
relates to the project settings and yeah, you've got
yeah,
scene
so
scale, which you can edit.
in that case, yeah, if you're working with small values, small geometry, etc., you would need to adjust then your scene scale because Cinema 4D has like a default sort of like scaling for a lot of its stuff. And so
Mm,
by default, yeah, it is set to 100 centimeters. And as like when you create a cube, its default is 200 by 200 by 200. So if you are working at a small, like that's like a nice scale idea of like how Cinema 4D does it, is by creating a primitive and seeing how your sizing of objects relates. And yes, you would need to then adjust your scene scale to kind of compensate for that.
cool. Thank you. Someone has asked, would it not be easier to use a MoSpline where the rope spline would and it's profiled the way the points would be even?
So the points are even anyway on here. the points will be even because we've set our points to uniform and they are set to 80. But yes, we could effectively use a MoSpline. Yeah.
Yeah, in theory. It's a
Yeah.
possibility. It's just another type of spline, isn't it, really? That's cool.
Yeah.
I
I
did
was
think
wondering.
we could, but.
Yeah.
And another quick question. What's the difference between using a floor, a plane, or a very thin cube to serve as a floor? Which is better?
Okay, so this is a plane. I renamed it, so sorry, that's probably where the confusion comes from. This is a plane. The floor would be fine, give you the infinite floor. The only reason I naturally don't really use the floor anymore is because it doesn't, oh, I might be wrong here now with the new things, but the floor doesn't really work with Redshift. You don't get infinite, yeah, the infinite floor
didn't work
doesn't
with
work.
Redshift when we wanted to do render. That's a good point.
Yeah, so my default go-to is a plane for that reason, and I don't use the floor for that reason. You could use, yeah, a thin cube. I guess the benefit of using the like a thicker object, for example, a cube, would be because there is therefore more geometry, the collisions would probably be better because you have a larger piece of geometry as opposed to a tiny thin plane, which if a particle then moves between a substep or a frame, it might miss it. Whereas let's say you've got like a thicker bit of geometry, by the time the point kind of like hits it, it may not have exited before the next frame, and therefore it would be more likely to catch it. That would be my advice.
That's
But
cool.
yeah, as
And
we
you're
see
right.
here, it works. Yeah.
Sorry, the floor still doesn't support Redshift.
Yeah.
Because if you change your renderer to Redshift, the floor object disappears. You can't actually make it. So
yeah,
that's
so that's
why
the only reason I don't use the floor by force of habit, is because I use Redshift all the time. But yeah, plain, or as we saw here, plain works fine if we adjust our collision and post-collision passes. But yeah, again, also a slightly thicker piece of geometry would work, and would perhaps work better with the collisions.
Cool. Thank you very much.
Cool.
Yep, that's all the questions.
Right. Wonderful. That was good. Right, so let me chuck this back over to Matt, so then
Woo.
we can learn about C40 particle emitter. Let me.
I think I renamed myself, so
Oh, okay.
so you can actually see me now.
Okay, there we go. Matt. Do you know what I find? Like changing the presenter and speaking seem to be two things I can't do at the same
What
time.
I don't understand about GoToWebinar is why it allows us, why the two organizers and not the top of the list. And I could, in theory, accidentally send the screen to any one of our 200 attendees.
I'm waiting for the day that I send an invitation to one of you wonderful people to present live with us, apparently. Cool.
Oh, someone has said, I see you're on a Mac. How are you using Redshift?
I like this question. I like talking about this. Okay, so there are a couple of reasons, actually. So first of all, Redshift GPU. So I'm going to separate them, Redshift CPU and Redshift GPU. As of Redshift 3.5, we now have an option for both. I'm using Redshift GPU, and that is because it's actually available and it works on particular graphics cards on Mac Intel machines. And so this is an important thing. I am on an Intel iMac currently, and I have a AMD 5700 XT. And what that means is on the Navi cards and the Vega cards on a Intel iMac, it works. GPU works. It also works on the M1 Apple machines. And then most PC machines with NVIDIA, and it also now works on PCs with AMD cards. So that is the question, and that's the answer to the
Yeah,
GPU side of things. That was a lot of kind of like, as you can tell, I'm
that's all
not
right.
very technical.
As of,
So
was it last
ask
year,
better.
basically, Redshift was able to support Mac again. And it was
Yes.
because Apple stopped supporting the NVIDIA drivers. So Apple had, Redshift had to basically recode their ability to talk on AMD drivers, but only on Mac. And now, like you say, it's now AMD also on PC. So
Yes.
Redshift
And
is,
then,
it's very,
so I was going to say, the flip side, the other half of that is as of 26 and Redshift 3.5, we have Redshift CPU. So Redshift runs on the CPU as well, which means pretty much anyone, any machine can actually use Redshift. And it is the same version, apart from Redshift RT, which we won't be talking about. And so,
yeah, I was just about to
yeah,
ask you to show something and then realized that I've got the screen.
oh, the switch between CPU and GPU.
There it is, yeah.
Yeah. So yeah, anyone now can use Redshift CPU within reason on their machine, and it is the same version of Redshift. I want to kind of like clarify, like inside of Cinema 4D, it's the same version. So you can do the same things, create the same materials, follow along with all the stuff that we're doing. It is just a little bit slower because naturally
Yep.
GPU is known to be a faster way of rendering. And if you have a machine that is capable of using Redshift GPU, you can then get a subscription of Redshift and it'll work on your GPU.
Yep. So if you have S26 by default, you will have access to a CPU Redshift renderer. You will not be able to access the GPU device or enable it unless you have a Redshift GPU subscription or Maxon One. So
Yes.
by default, you can have one, but not the other. Quick one coming in, M1 Redshift is CPU only, but that's not true, is it? The
No, not the case.
M1 Max
M1, yep,
will
M1
use
Max Pro
CPU.
and
Yeah,
the other one, Ultra, GPU Redshift.
yeah, that's what I thought. Cool.
Yeah. So the purpose of the CPU is for people perhaps on kind of like the slightly older machines, slightly older graphics cards that aren't
Yeah.
optimized for GPU rendering. You can now use CPU. But yeah, if you're on M1, you are good to go with GPU.
Woohoo. Right, cool. I've got about 10 minutes now to show
Oh no,
you
don't rush, don't rush. Honestly, we're good. We're
particles.
good.
What am I doing? Who am I? Okay, so let's have a look under the simulate. So let's look at particles. Particle emitters, yay. There are, in theory, two particle systems inside of Cinema 4D. At this point, I'm going to show you the basic one. Because actually, considering that it's basic, you can do a hell of a lot with it, which is really nice. So I create a particle emitter. Ta-da. Oh, I need to turn my camera on, don't I? So you can see me yabba. There we go. And then press play. Ooh. Particles. There we go. I'm done. Thank you very much. As you can see, we can create particles. And again, I'm going to give myself a bit more time to explore and let the particles do stuff. The particle emitter has a basic set of information, which is quite interesting and easy to configure. So as you can see, my particles have just stopped. And the reason for that is because they have a stop emission. So I can tell particles when to start and when to stop. So let's give it 500. So, oh no, not 1500. So it's going to keep going. I've already exceeded that. So it's going to create these particles, which is really nice. You can then control the number of particles that you can see via an editor, which is an animatable object. So you can increase the number of things that create. You can also increase the number of particles that are visible in the renderer. You can see that it stops at 500 again. We've got lifetime, which is the number of frames that these things exist. You can choose the variation, you can choose speed, you can choose speed variation. So let's whack the speed up and you'll see they'll go faster. Whee! And then I can whack the variation up and some will go far faster than others which aren't going as fast. If I look in here, I feel like I'm in Star Trek. Or in reverse, actually, I'm going backwards. But that's just a little bit of silly fun. So the particles, say, is quite nice to play around with and maneuver. Now, particles actually don't exist. So if I render, which I don't need to be doing in Redshift. No. Particles don't exist. Ta-da! You can see no particles here. If I want it to emit something, then I need to put something in the emitter. That is a ridiculously large sphere for this. So let's shrink the sphere, put the sphere in the emitter, and now render. And I can see the particles. If I go back to the beginning and press play, you can see that the particles show up on screen as still the sort of dummy particles. And if I render, they show up. If I want them to show up more, or actually be visible inside the viewport, then on my emitter, I can click show object, and you can see that they are now there, and they will emit. And I can watch this happen. I can watch them go all crazy. I can watch them get more and more. I can watch my poor machine grind to a halt the more particles there are on. So let's kill some particles by decreasing the lifetime to about 50 frames. And now stuff will disappear and it will kind of bubble its way along. So there won't be that many particles on at all points, but they'll last about 50 frames. And that's kind of the particle emitter in an absolute nutshell. You know, you can change sizes, you can change the emitter, you can change the shape that it creates. You've got how wide it is, how tall it is. You can change the amount of angles that it'll go, you know, out at, which I really like. So rather than just being, you know, completely flat or in entirely one direction, I can choose that it will go in different angles and different angles vertically as well. So I can have stuff go all over the place. And it's quite nice to create. So I can create like bubbles coming from a central location rather than just particles going in one particular direction following an exact stream. So it's something that's quite nice, and you can play around and mess around with, and you get some interesting effects. I can even move my emitter around and particles will come out of it from wherever it is. So that's something you can animate as well. Particles can be affected by things like gravity. And so under the simulate, we have some forces that we can use. And let's create some gravity. And if I create some gravity and press play, all of my particles now fall to the ground. Okay, so that's quite a nice effect to have. You can, if you want to, turn off gravity, and let's create some different forces. So we can have attractors, we can have rotation and turbulence. Turbulence is one of my favorite ones, because it gives them a bit more movement, which I may need to turn up. So let's whack the strength up, and let's whack the scale up. And you'll find that they'll move around a bit more. I'm going to increase there. I'm just going to turn off the sphere, and then I need to turn back off in the particle emitter, show objects, so that I can just see the particles themselves. And it means I can increase their length, lifespan again, to something where we can see the particles move around a lot more. And you can see that they're not just following straight lines, they're kind of swarming now because of what the turbulence is doing. If I turn that off, you can see that they're much more direct, and then turn it back on, and then they kind of swarm and move and swirl around, which give you some just really interesting effects that you can have some, you know, fun with. I mean, obviously we know that we can create spheres with all of these and then render, and it will render these dots out. It will also, if you want to, let's create a secondary object and put the secondary object in the emitter, do both. So I can have cubes and I can have spheres in there as well. And it's simply, I think it's every other one. So there's no sort of randomization as to which one it does. But you'll get a random effect the more objects you have in there. So you can even change sizes and scales. So you can make them bigger or smaller depending on the length and the lifespan that these objects get. So you'll be able to create more interesting, wow, that's crazy, more interesting effects just by changing these little bits of information to give you more random, more variety, more interesting effects and looks. So we know that it uses turbulences, we know that it can use gravity. Emitters can also be dynamic. So this is going to be the old school dynamic stuff. So I'm going to create rigid body dynamics to the emitter. No, I'm not. I need to do it to the objects, otherwise stuff falls down. Ooh, do I? Let's just get rid of that. Interesting. Why is?
Are you hoping it's gonna do emit spheres and make them dynamic?
Yeah. What have I done
Could you
wrong?
go onto the? Could you click onto the emitter, please?
Show objects.
Show objects. Yeah.
There we go. Sorry, it doesn't do it with the particles themselves. It's too hot today. My brain is failing. But you can see that it's now having, so this isn't to do with the gravity. Thank you, Ellie. This is to do with the dynamics. And if I create myself a floor, which unfortunately Ellie won't be able to use in Redshift, I can add a collider body to the floor and the particles will collide, which is really quite nice. So you can add some different effects. You can add gravity in different ways. You can add attractors to pull them all to one direction. And all of those other forces that you can use all exist here under the forces direction. And the attractor, this is getting a bit crazy. So if I move the attractor kind of over there, and let's whack the strength up to something ridiculous. You can see that certain stuff is kind of trying to pull in to the attractor. It's quite subtle, but it is happening. So there's a lot of stuff that you can experiment with and play with and see what you can do. You can see that we've got that kind of clump there where the attractor is. It wasn't doing an awful lot. You know, maybe need to increase its size, or you can use fields to do it as well. But there's sort of hosts of things that particles can be used for. Now, as I've said before, in order to be able to see them generally, you need to create some form of something to emit. However, that isn't always the case. And of course, thanks to Redshift, we are able to render out the particles and create more interesting effects without the need to create objects. And unless we have any quick questions, that's where Elly will come in.
One quick one from,
Okay.
actually possibly two quick ones, from Marcelo, who's wondering, could you change the scale of the spheres over time?
I mean, technically you could animate it. There's an N scale, so in theory it should shrink, and then you could choose the variation so that not all of them do. I think you can do a -1. No, you can't get any lower than that.
And if we're loving the quick and dirty ways where, yeah, you could just animate the sphere size,
shrinking, but I don't know if it would. Yeah, in theory it should do it per one. Rotation variation, N scale. Yeah, you can't actually go below, so you can get stuff getting bigger, but you can't have stuff shrink as it dies. No.
Yeah, I'm just trying to think
Anything
how. I think, yeah, no, I think that's it. We sort of said, could you make like a rain simulation? Yeah, you
Yes.
could have the emitter kind of either point like facing down, so as it emits, then add gravity, and as it falls down, then you could take it a step further by, no, I mean, this is taking it a lot step further. You could then combine it with a vertex map to then, as it hits, you could then create the ripple of the rain. So there are some very cool things, but I feel like I should also plug, this isn't information that's known yet, but I feel like I'm allowed to share these things. Next week's Demystifying Post-Production series, next month, will actually
July,
be on particles and that will be across the Maxon tools, so and other tools. So not only will we be looking at, you know, thinking particles, native C4D particles, but also my good pal Chad will be showing you how to create particles in the Red Giant tools. And you know, I believe Lionel will also be there and sharing some of his amazing X particle knowledge too.
Cool.
So boom, thunder stolen. Sorry guys. So yeah, if you're really
Awesome.
interested in like the next kind of like
Shameless
this
plug.
hour that we're doing, shameless plug. I mean, we're all in the Maxon team, right? I'm allowed to say these things. Oh, Chad's just said and Houdini. Ooh, all right, Chad, stop showing off. So yeah, if you're really interested in the stuff that we're covering and you want to know more about particles, absolutely July's Demystifying Post-Production series, which is Mondays at 9 Pacific time, 9 a.m. PDT. But if you can't wait,
Houdini, apparently, but I'm not sure
yes,
that's
and Houdini.
um,
But if you can't wait until July, then let me show you a cool little setup that I actually posted on my Instagram recently. And people were like, how do you do this? And it's just using this native particle emitter, Turbulence, and we're going to combine it with Redshift. So
there you
let
go.
me, how do I get this? Share my screen. Cool. There's a lot of ways to make particles. Yes, there is. There are many different ways of creating particles, but hopefully, you know, that'll be the purpose of the demystifying series. And Mimo's on, and can we create smoke like that? Puffs of smoke from a steamboat. Yes, there's so many different ways that you can create smoke. You could use like an emitter in a volume builder and then do the fog workflow that we did in the volume session last week. So maybe I'll throw that into the last session of this, the one that we look at Redshift. Maybe I'll do that. Okay, cool. You can see my screen, right? It's there.
We can.
Cool. Right, so let's create what I think is a really, really cool looking particle setup that really is actually not that advanced. So this is the setup. We're not going to create this entire thing. We're going to do kind of like half of it. If I play this through, we can see that we have two emitters, and it's kind of like all spiraling in together, and it's eventually gonna come in, and we have this really nice like turbulent effect. And I think it looks relatively intermediate or advanced. And then if we combine this with Redshift, we can actually then render all of these particles without having to worry about slowing down performance. So let's look at how we can actually set this up in good old trusty Cinema 4D native particles. Cool, so feel free to follow along. I will, you know, talk through pretty much the entire setup that we're going to do from scratch. So first things first, we of course need a particle emitter. So we're going to come into our simulate menu, we're going to grab ourselves our emitter, and let me just turn off my work plane. And then, you know, if we press play, we have our particles. Cool stuff. Let me just increase my timeline. My reason for that is I want to have some slow particles, and I want them to like be turbulent and whatever, and therefore 90 frames is just not enough for me. So let's go 600. I'm not too fussed about this, but it's going to give me enough time to actually play with this stuff. And the only other thing I'm going to do is I'm going to rotate my emitter so it's facing up on my Y direction. Cool, now as I press play, my particles are going up, and that's what we want, In the original setup, we can see they're kind of going round in a spiral. So we're actually controlling our particle direction. And there is actually a couple of different ways that we can do this, but I'm going to show you the quickest and easiest way, and that is by using a spline. And we can use that spline to then tell the particles, hey, follow me, base your direction on me. So we can do that. Let me move this out of the way so I can actually see what I'm doing.
I just figured out the particle scale issue as well. I'm a muppet. You can't set it to -1, but you can set it to 0. Setting it to 0 means that your particles can shrink over time. Sorry.
Oh, that's cool though. That is cool. Right, so what we're going to do, let's set up a spline, and this is what is going to control the direction of my particles. So one of the coolest looking splines, if we're allowed to have a favorite, is the helix spline, and it's just going to give me this nice preset spiral. And what we're going to do, we're just going to change its orientation to XZ, so it's kind of going to go up like that. And then we just need to control and adjust a couple of these settings. So I'm going to change my start radius to 30 and my end to 15 and just pull it all in a little bit more. I then want my height, let's go 300 for my height. And then my end angle, so you'll probably notice that we're not having a lot of like spirals going on. It's not like a really tight helix, and that is because of my end angle. So all I need to do is up my end angle here. Maybe we go something like 1600 degrees on there. So we now have our helix spline. And so inside of my emitter, one thing I'm going to do, I'm going to make it smaller, and two, I'm going to position it so it's nearer the start of this helix. And the reason for that is when it comes to changing the direction of the particles, this is just going to help make it look like they're being created in one area, and then they're going to be following the spline. So let me just make this a bit smaller. Okay, there we go. And then we're going to reposition this just here. It doesn't need to be perfect, just needs to be good enough. That is my motto. Cool, so as I press play, nothing's happening. They're not actually following the helix. And the reason for that is we need to now tell our particles, okay, we want you to change your direction based on this helix. And so the way that we do that is inside of our simulate menu, we have a very wonderful and powerful tool called the field force. And if I select my field force, it allows us to combine, if you're used to working with MoGraph or used to working with fields, it allows us to combine the power of fields with the power of forces. And so effectively what the field force is, it is this bounding box area that is going to display what are called spatial vectors, and they are going to be what control the direction or velocity of particles, or we can do it with dynamic objects. It effectively can, the field force can affect anything that has a force tab on it. And so I can show you what it does. I can show you what it means and what it does. So what we want to do first of all, the things that are going to be affected need to be inside of my field force bounding box. So that's what this green area is here. So if I go to my display, we've got our display box here. I'm going to make it 100 by 300 by 100. My reason for this is because I've just set my helix to be 300 in height. Therefore, I know my field force needs to be 300 in height, and then 100 centimeters should be good enough to fit everything in. So if I just pull this up by 150, we can now see, oh look, it fits perfectly inside of here. And so now all the particles inside of this bounding box are going to be affected by the settings that we set up. So again, nothing's going to happen. And this is because we actually need to then change some of our field force properties. So the first thing we want to do is we have a velocity type. So we have add to velocity, which is going to add to the velocity of our, in our case, particles. We can set our absolute velocity, which means whatever we put in here, let's say we put like a random field, that would be setting the velocity and overriding any velocity and previous sort of speed settings. But we also have our third option, which is the one that we're going for, which is change direction. And so what it's going to do is going to change the direction of our particles. But the next step is we then need to tell the field force how to, like, the rotation of the vectors, which are in turn going to be controlling the direction of our particles. And as soon as I add in the helix, that is going to make total sense. So we're going to drop our helix in, or whatever we're using to control our change in direction. We could use a field, we can use splines. Drop that in there, and you might be able to just notice a couple of little lines here, and these are what we call vectors. Oops. If I go into my display, I increase my line density and I increase my line length, hopefully you guys can see that the vectors are now basing their position or their rotation and their angle on my helix. And so what that means is now, as my particles get emitted and they're inside of this field force area, they're going to see these vectors and they're going to kind of like follow them around, and they're going to follow their kind of angle of rotation. So we don't need to see our display box. We also don't need to see our helix. So we can just press that little, so we turned our field force off here just by display box, and then we just do our little traffic light on our helix so we don't see that. So now something's going to happen when I press play, and I know this because I've done this setup before, but I want to show it. Our particles are going the wrong direction. They're kind of being born and being like, no, I'm going the wrong way. And the reason for this is our spline actually needs to be reversed. So what's great, inside the helix, we have a really wonderful reverse button. That's because it is a preset spline. So I can reverse this and it's going to reverse my spline. I also want to mention, if you are using a different spline or a spline that doesn't have a reverse or something that you've imported or drawn yourself, if you press Shift C, you get the commander, and I'm going to be testing myself now. I think there is a reverse sequence. I believe Matt may have to correct me if I'm wrong here. Reverse sequence should then reverse the order sequence of your spline. So
yep, you can just select all of the points and then right click, and you can go to change point order and you can reverse them that way as well.
Oh, cool. There you go. 3 different ways to reverse spline. Perfect. So now we've just reversed our helix. As we press play, it's going to do what we want it to do. Perfect. So it's now following that helix. There's a couple of things. Let me play it through. Okay, cool. A couple of things that we are noticing. For a start, my particle emitter has actually stopped emitting at a certain frame. But what we want is we want a continuous emission. And by default, it actually stops emitting on frame 150. But that's fine. We can fix that. It's also when we haven't got enough particles. I mean, you're probably looking at that and thinking, Ellie, come on, what? You've only got a few particles. So yes, we can then adjust our particle amount, and I'm also going to adjust the speed of my particles because everything's happening a little bit too quickly. So let's change all of these settings, which Matt has just shown us anyway inside of the emitter. So birth rate editor and renderer. This is where we control the amount of particles. I'm going to go big. Let's go like 800 and 800. And the reason that I'm going 800 is because we're not going to be creating or generating geometry inside of the viewport. We're going to be using a little trick with Redshift. And so we can actually have quite a high number of particles. And I'm not worried about performance because only in the renderer are we going to be creating our look of geometry. We then have our stop emission. So we can see that our particles are stopping emitting at frame 150. We don't want that. Let me just put this to 600 just to match my timeline. And then our speed. So our speed is very fast. I'm going to set this to 15 and I'm going to set a variation of 50%. And what that means is we're going to get some particles that are going this speed, some that are going to go 50% slower, and some are going to go 50% faster. So it creates some nice randomization and some nice variation as well. Let's play this through and just see what it looks like. Okay, so admittedly a little bit more interesting than it was before. However, it's still looking a little bit uniform and it's not that interesting. Well, from this point, we can actually add some forces and we can create some more interesting results by just combining a few of these elements together. My favorite thing inside of the kind of the forces menu, maybe aside from the field force, is turbulence. Turbulence makes everything look cool, especially with particles. Just throw it on, looks great. So what I'm going to do, we're going to come into our simulate menu. We are going to go to forces and turbulence. So inside my turbulence, we have the strength of our turbulent effect on our particles. We then have our scale, which is going to define, so imagine you have like a noise over the top of this. The scale is going to define the size of that noise. So the smaller the noise, the more random our particle movement is going to be, and the larger, the more noise will sort of move in flows together. So it will sort of like almost take a section of our particles and they'll be moving together, another section will be moving together based on, imagine like a really big like noise over the top of here. And then we have our frequency, which if we lower the frequency, the noise will change more slowly. If you have a value of 0 on frequency, it will be like the noise isn't animated, so we'll have static noise, whereas this will make it look a little bit more sort of like nice and flowy and add some realism to it. So let me have a quick think, what do I want to do? Let's go to a strength of 20 centimeters and a scale of 10. And so actually, you know what? Let me just switch that off first so we can do a little nice comparison. So this is what we had before. Now we're going to switch on our turbulence and watch the magic. So we can see just how much of a difference one simple force has made to this. It's just created this really awesome looking kind of like noise pattern, turbulent effect on our particles. And so from here, this is the initial setup. This is what I originally created when I was doing this sort of thing. But then what we can do a real quick trick by just duplicating our emitter. Let me just change the color of this one so we can see the difference. So this one by default is set to green. This one is now set to red. Inside of certain things inside of Cinema 4D, I know that's not very accurate at all of a description, but there is something called a seed value, and it is a random seed value, and it allows us to randomize the things that are happening in a particular object or tool. So in the random effector, for example, or in noise patterns, they have a seed value which can be changed, and therefore we get a different random pattern or a different noise pattern. And this works in the same way. I can change the seed value of this second emitter. So let's call this emitter 02, and this can be emitter 01. And so now what's going to happen, the birth rate is going to be different, the speed variation is going to be different, and we're going to be able to see that these two emitter setups are actually going to be kind of working together but having a slightly different look. And it's just a nice way of adding even more randomization and even more variation, like we can see here. So I really like this setup. I think it's so cool that you can create this kind of stuff with Cinema 4D's native emitter. And then from here, what we can do, we can take this to the next step and to the next level by creating a type of geometry inside of the Redshift renderer. And so that means that's allowing us to have a load more particles because we're not actually worried about physical geometry. So the way that we set this up, we're going to change our renderer to Redshift. And just really quickly, because I want some really just simple lighting all over, I'm going to drop in a dome light, and oh, it's very bright. And I'm going to switch off my background so we don't see that. And then let's add a HDR image. So that's the joy of working with a dome light, is we can just drop in a HDR image in here. What one do I want to do? Let's go with that one. Cool. Great. So we've set up some really quick lighting, changed our render to Redshift. Those are sort of like the initial steps for this. And then I'm going to open up my Redshift render view and drop that in here. And just for the sakes of this, so we can all see everything a little bit clearer, I'm going to change my output just so everything is sort of like side by side nicely. Okay, so we've kicked off our Redshift render view, and as we can see, we see absolutely nothing. And that's because we need to do a couple of steps in order to be able to see what's in our viewport and almost create Redshift geometry or render some Redshift geometry. And the way that we do that is by using a tag called the Redshift object tag. So if I right click on my emitter, so it's important, it needs to be on our emitter here because we're going to be converting our particles into objects. So right click the emitter, Redshift object tag, and it's clever enough to know that it's on an emitter, therefore we get a particle tab. So if we put this on something different, we would get a different kind of tag here. And so inside of our particle mode, at the moment it's disabled. So if I press play, we see nothing. But if I drop this down, we have a couple of different options. I'm just going to change it to sphere instances for now. Now, inside of our render view, we can now see that we have a sphere instance for each particle. We can then come in and we can adjust our sizing of these. We can then, duplicate this on here, and we could have then a different size. So we have some that are larger, some that are smaller. And one thing that I like to do, and the thing that I initially did on kind of like the Instagram post, is to make these look like individual pieces of rock. And the way that we can do that is if I just sort of come into a second window just so I can demonstrate this quicker. If you grab yourself a sphere, I'm not too fussed about segments for now, just demoing. There is something called the Voronoi Fracture, which is a MoGraph generator, and it's actually something we're going to be learning about next week. A little preview for you here. So I'm not going to worry about going into it in too much detail, but effectively, if we add an object and make it a child of it, the Voronoi Fracture splits it up into individual segments. So if I come into object, I can offset these fragments, and you can now see we have different individual pieces. We can then control the amount of points, which in turn is controlling the amount of fragments. Increase that so we get more of them. And what I'm going to do, I'm going to use this trick and use this effect, and then we can set inside of the Redshift object tag, we can set objects as like a custom object that will then be rendered as opposed to the spheres that we're seeing here. So what I'm going to do, I'm going to very quickly do that same setup, grab myself a sphere. I'm going to make it 10 centimeters, and we can't see it, it's out of shot, but I know that it's doing what it needs to do. Drop my sphere into my Voronoi Fracture, and I'm going to create, might be a bit overkill. Oh, definitely overkill. We're going to go 150 points, so we now have a lot of different kind of pieces. If I pull it up, we can see it all down there. And then what we need to do, we need to convert these into individual objects, which we can then drop into this area here. And so really easily, we can convert this Voronoi Fracture into individual pieces by hitting the C key, which makes it editable, which is this option here. And now if I open up my null, I have all my different sphere pieces, all of them here. So let's kick off my render view so we can see this happen. Let's just change this to 1 for now. Change this to 1. We're going to change our mode to custom objects. Everything's going to disappear. If I just switch that off, everything's going to disappear. And now it's saying, okay, what custom objects do you want me to render in the render view? And so what we can do, I'm just going to lock that so we can grab all my sphere pieces, drop them in. And if you watch the render view on the left-hand side, we now have our rock pieces. We can then make them smaller by adjusting our scale multiplier. And we can do the same thing. So if I delete that and bring my second emitter back, duplicate this one, and then let's have some smaller pieces. We then have our rocks. So our particles are now being rendered as these rock pieces that we just set up. And then the final step would be double clicking to create your own Redshift material. And we're going to dive into Redshift materials in probably weeks 5 and 6 in more detail. So we have our node editor here, and we can control our color. So let's create just sort of like some dark sort of like rock pieces here. So let's make these darker. And it would be wise if I then dropped the material onto the object. So all we have to do, drop it on the emitter. Sorry, not onto the emitter. Drop it onto the Voronoi Fracture. So the custom objects that you are rendering, that's what needs to have the material on. So we now have our shiny sort of glossy material, which I think alone looks pretty cool. But one final thing, we could add some bumpiness to the surface to give it more of like a sort of like a rocky detailed thing. So inside of material, your normal standard materials, you would enable your bump channel, and you'd then add a bump texture or a noise or something. We're going to do that exact same workflow, but we're going to do it inside of Redshift's node editor. So we can access our nodes by just double clicking. Then we can type the node that we want, and we can actually use Maxon noises inside of Redshift and inside of the node editor. So I've typed in Maxon noise. I'm going to drag and drop it into here. Now we have that. Now what we need to do before we can plug it into our Redshift material bump map, we just need to add a bump node. So think of this in the same way that you would enable the bump channel. We need to enable the bump by adding the node. Again, double click, aptly named bump map, drag and drop that in here. And then all we need to do is connect these things together. So we go output of our noise, goes into the input of our bump, and then our bump goes into our bump map. And now we have a whole bunch of bumpiness going along here. We can actually sort of close this down. And now we have the bumpiness on our surface. We can even come back into our material, and inside of our noise, if we want to see how it looks, solo it. And then what we can do is we can control our Maxon noise. So you'll recognize all of these as our usual Maxon noises. So if we go, I think Poxo works as a cool one. So we have all this detail now on here. If we unsolo that, we now have that as the bumpiness on the surface of our rocks. And we can see that's a little bit too big, so we could adjust back inside of our node editor, inside of our bump. If we want to adjust the height, so normally we're used to seeing the percentage of bump height. We work with a numerical value here with height scale, so we don't do like percentages. And I can just drop that down to maybe like 0.2, make it a bit smaller. And now we have a bit of like a particle rock simulation. And I mean, if I played this through, I don't know how fast it would be, because I've got my render view. I got my render view now playing, but you can see how if we rendered this out as an animation, this is what we would get. We would get an animation of all of this cool stuff. And all it really is an emitter following the helix, using the field force to change its direction with a turbulence. And then the way that we are getting our render and we're getting our geometry in our render view is by using the Redshift object tag set to custom objects, which we then created really quickly using the Voronoi Fracture. Any questions?
No, you've wowed everyone into silence. Oh, no, we've got a couple. Here we go. Can you get motion blur?
Yep. So inside of your Redshift settings, we will be covering these in week 6. We can actually do it inside of the basic tab. We can enable motion blur, and then you control your steps for, you know, how much accuracy of your motion blur. And then I think in advanced settings, yep, we have more advanced motion blur settings as well. So yeah, just check that on. I mean, basic works pretty well, especially if you're new to Redshift. Switch that on, and then you will render out motion blur.
Sweet. How would you apply multiple materials to the rock instance?
Ooh, so
Now,
many different ways. So
yeah,
I guess I'd say the simplest way of doing that, maybe not the simplest way. Okay, so you could apply a material to each individual fragment piece. Yeah, that would be one way of doing it. Another way of doing it would be to actually use a technique we're going to be learning in week 5, which is using MoGraph color and particle color. So
yeah,
I won't go into that now because that's we're going to be diving into color user data and we're going to be diving into Redshift, and so I wouldn't want to rush that. But absolutely, yes, that is possible, and we're going to be taking some tricks and some techniques with like color type workflows like color user data, MoGraph color, object ID color, and then we're going to look at how we can adjust and control different materials using those different workflows and techniques.
cool.
A little
So
preview
stay
there for week
tuned
5.
for a couple of weeks, and we will explain how to do that. Is it possible to set an accurate alpha AOV for the particles?
I'm not sure what you mean by an alpha AOV. Do you know what that could be, Matt?
No, afraid not. I don't have
So
dealings
yeah,
with AOV.
so we can look at AOV. So AOV manager inside of the render settings, then we
Oh,
can show our AOV manager.
just without background. So just an alpha channel, I think.
So like we can do like a depth,
I
like
think you
a
just,
Z depth pass.
can you just get rid of the background? And is it possible? So we just have basically the particles on their own layer, and there's no background.
I'd imagine so, yeah. So how would I do
Someone
that?
has said Cryptomatte would work.
Yeah, that would work. So Cryptomatte would be, so Cryptomatte's going to give us, yeah, I wonder if it will give us all of them because it does individual objects.
Burnt's also suggested, could you add the Redshift object tag and enabling object ID? Can you render out only a single object with Redshift? Like that, you can choose the particular one.
Yeah, so the trouble with Cryptomatte is it's going to give each object a different one.
Wow.
So that's not what we want. PuzzleMatte could work.
Yeah, someone said you could PuzzleMatte by material.
Yeah, I was gonna say PuzzleMatte could work, and then we can change it object ID or material ID. And then, okay, so let me get rid of that. Have that in the way now. Okay, so I'm trying to think. So my material ID, where do I change my material ID? See, this is things that I've not really done. Assignment. If anyone knows, please let me know where to find material ID.
Or
Hang
could you
on,
do just object ID and then
let's
add
see if that
the,
could work.
yeah, the Redshift
And
tag to the group?
I'm going to see if it works on the emitter first.
Oh, okay.
I'm going to see if that works first. Object ID set to 1. Let's set that to 1. Kick that off. PuzzleMatte. I might need to bucket render. This will be interesting.
It looks a bit.
That does. Okay, that's fine. So let's do object ID on here instead. Take 2. Hey,
Ooh,
there we
that
go. So yeah, I don't know where to find the material ID actually. That's a good thing, but I'll find that out. But yes,
material
object.
ID is in the output node.
Oh,
So do you have
thanks.
to add an extra node in the thing? Thank you
No,
to
it,
Mike for that, because I didn't know.
how, yes, love that. Okay, cool. So yeah, I just set up the object ID, and then just set up the object like tag for here and set that, which is
Oh,
great
okay.
because then we can set up multiple different ones. But then who was it? Is it Mike?
It
Was it
was
Mike?
Mike.
I've already
Thank you, Mike.
forgotten. Mike. Thanks, Mike. Yeah, output node, material ID in here. So yeah, PuzzleMatte and your AOV manager. So yeah, Cryptomatte, what it does is it will just, each object name will be given a different sort of color. So
Mm.
nice, but in our case, not nice, not what we want. But PuzzleMatte we can now put in there, and we can set object ID, or as you know, Mike showed us, we have our material ID, and then you control your red, green, and blue channels based on the IDs, and you can actually have duplicate PuzzleMattes and have different ID numbers. So we could then go like 4, 5, 6 if we want to.
Cool. Thank you. James
Cool.
has asked, can an emitter be in the shape of a volume? For example, a number that becomes the particles. Is that still in the asset browser? Because I swear we've got that set up. I'm just going to have a quick look.
I'm guessing particle. Thinking particles seen. Oh, like the field force number, or is it not
I think it was the field force one. Yeah.
a field force one?
Yeah.
Yeah, so that would be,
Because
yeah, the
this
field force.
isn't actually, the emitter isn't the thing that's changing, but there's
No.
some other fields that relate to different things. But this may be a solution to what you were after.
Yeah, so what's happening is inside the field force, you can actually put in your volume measure. So like the volume builder workflow that we did last week. So for example, in here, they have their MoText, which is set up, MoText, which now is text
Oh,
inside of a
just
volume
text,
builder,
yeah.
inside of a measure. And that measure is then put inside of here. And it will say, do you want to do it as a point object or a volume object? It needs to be, I think volume object. Basically just go with point object. And then this is now controlling the velocity. And I believe, is this just like, I don't think this even uses an emitter. No, it doesn't.
Oh, it's
Does it? Yeah, it doesn't use an emitter. No, so we have it's using a cloner.
oh, just creating thingies. Cool, sweet.
That's quick as well. I'm well impressed with that.
Mm. Um, I think that's kind of all of the time that we have, really, as it's
Yeah.
8 minutes past. We never overrun.
We never overrun. Okay, yeah,
Uh,
that's cool. Did we have more questions then, or?
um, one or
I think
two.
we're good.
The serious question is that where is my cat? And my cat today, being very strange, is currently sitting on a fleece in a window, baking himself in the sun. Who knows? Cat likes to be warm.
Okay, cool. Yeah, so quickly, really quickly before we wrap up, you know, we like to give you a little bit of a teaser about what's happening next week. Let me just kick this off. So, working with motion, we already sort of had a little bit of a talk about what we're going to be covering. You know, we talked about some of the MoGraph stuff, and then some like the Voronoi Fracture. So this is a vague-ish plan of what we're going to do. We're going to decide this in a bit more detail, but this is the idea of the topics we want to cover. We're just not 100% sure on the practical just yet. We may change our mind like we love to do. So we're going to be diving into vertex maps. very cool, very powerful inside of Cinema 4D, and can be used at a wide range of topics and disciplines. Something we didn't cover in the beginner's workshop, but something, I mean, I think this might have been the whole idea as to why we then did a level up workshop, because we were like, vertex maps would be cool to show. So we're going to look at how we can set those up and how they work. Then we're going to look at combining vertex maps with a few different workflows. And we think we'll be showing it with the MoGraph and the fields workflow, because again, very powerful, really interesting results, especially when it comes to motion graphics and animation. And that's the kind of premise behind part 4 anyway. Then we're going to have a closer look at the Voronoi Fracture. So we looked at it in a little bit of detail, a very small amount today, and also in the previous workshop. But there are many things we can do with it that isn't just kind of breaking an object apart, adding rigid body dynamics and watching it fall, which is a lot of fun. We all love to do it. And I think it's the first thing we all ever did with the Voronoi Fracture. But we can also create some really interesting animation and then control that animation with splines, fields, and create interesting results. And then we'll look at, combining it with MoGraph, rigid body dynamics, and then possibly create a ground cracking animation, or maybe something slightly different. If you have any suggestions or ideas, or would like to see anything, then feel free to let us know during this week. And yeah, it's a good week to fit in a lot of different setups, because as we know, MoGraph workflow is relatively quick to set up. Yeah. So it should be.
It'll be groundbreaking.
That's.
I'm sorry. It was too obvious. I just couldn't. It was there.
Oh God, that was a good one. Simon would be proud of you for that one. Okay, so I just want to say thanks, first of all, to you, Matt. Like, as always, like, incredible stuff, really lovely techniques. It's always so much fun doing these sessions with you. And thanks to everyone who not only asks questions, but is here watching with us live, who's sort of like just made a comment, said a shout out, and anyone who watches this on YouTube, we really appreciate it. We get that, time zones can be a little bit of a mess. I think someone said it was 3 AM in New Zealand just not that long ago.
Yeah,
so yeah, Jed, appreciate that. Like, that's some good commitment there. But yeah, we can appreciate that not everyone can watch these live. So anyone that is on the YouTube as well, thank you so much for taking the time to be on this workshop, on this journey with us. It's been fun, and we're only halfway. We've got three more weeks to go. So yeah, we will see you next week. Have a lovely rest of your week, everyone, and we'll see you soon.
Yeah. Bye. Take care, guys. Bye.